Hey guys, welcome to section 8.2. Hope the weather is treating you well. Hopefully it's warmer. Expecting 3 to 6 inches tomorrow. So hopefully you have your snow shovel ready to go. But for now, let's talk about exponential decay. Hopefully you won't see this happen to many of your investments over the course of your lifetime. However, this is basically what you're looking at. You're going to be looking at an exponential function, okay, where b is between the value of 0 and 1. So this value here for b is between 0 and 1. So as you start raising that to an exponent, the number keeps getting increasingly smaller. It gets real close to 0, but it should never cross 0. Like your parents when they buy a vehicle or you buy a vehicle, usually when you buy a vehicle, you buy it when it's the most valuable, and as you drive it, it loses its value, okay? That's exponential decay. So you can read this as you go down through the decreases in radioactive material as it undergoes fission and decays into other atoms. It's a curve of exponential decay. The discharge of an electric capacitor through a resistance can be calculated using exponential decay. The warm object as it cools to a constant surrounding temperature can be calculated using. So these are a bunch of examples here, as you can see. But let's show you how this basically works down here in the practice. I'm going to do it by hand. You very well can use your graphic calculator to type this in. And I'll show you how to do that after I do the run through, or I can do it with the first one. So what I'm going to do is I'm going to start with basically 0, and I'm going to work my way out from that. Now anything to the 0 power is definitely 1, so this is 0, 1. If I plug negative 2 in here, that's going to flip 3 over 4. So really this is going to be 4/3 squared when I get rid of that negative here. So this is 16 over 9, okay, which is close to 2. So as I start working to the left here, you can see this is actually increasing. Right? So this is 16 ninths. If I plug in negative 4 and I have 4 to the 4th, well that's fun, 16, 256 over 3 to the 4th, which is 81. So 81 goes into that about, let's say 3 times. Okay, so this is going to be about 3, a little bit past 3, right about here. Okay, maybe I should use the calculator for this one, huh? So if you're doing this on the calculator, and you bring that up, there we go. Y equals, we have 3 over 4. To the x. Now remember, the only reason I flipped this is because I did a negative 2. That flips it. So I don't want to type that in here like that. Let's go to our table. 0, 1, I was on the money. Here's negative 2, 1.7. That's about 1.7. Pretty good. How about negative 4, 3.1? There it is. How about negative 6? Negative 6, we're looking at 5.6 approximately. So that's 5.6, that would be about here. Okay, you can see this is getting a little bit steeper as I move out to the left. I'm just going to do negative 8 yet, and that's going to be it. So negative 8, we're looking at 9.9, 8, 8. So this is basically about 10. So negative 8, we're going to go up to 10. So 6, 8, 10 would be all the way up here. You can see this is getting steeper and steeper. Whereas if you go to the right, you can pretty much assume it's going to do the opposite. It's going to get less steep and less steep until you basically level out. So I'm going to do multiples of 2. So positive 2, I'm going to graph that point 5, 6. So 2, I'm about halfway. Right, 4. We're about at 0.32. So that's a little bit less. Still closer to the halfway point in that block, but we're getting closer and closer to the x-axis. At 6, we're at 0.17, so 0.18, just about here, and then we're going to get even closer at 0.1. Never going to quite get to that 0, though, so as we start to draw this, you can really see how that begins to level off. There's 3/4 of the x. Let me shift this over so we can do 2 quick. Okay. So if I multiply this by -3, it's just gonna basically make this curve get vertical a lot more quickly, I would think. So let's try doing this. I'm gonna type it in the calculator, so second insert. I'm gonna put -3 times that in here. And now I'm gonna go back to my chart. So let's see what happens here. All right, I'm gonna start at -4, because this chart is, like I said, a lot more vertical, more quickly. So -4, we're at -9.5. So that would be up here, because my chart only goes at 8. At -2, I'm looking at -5.3. So it's up here. At 0, I'm at -3. That one's here. I can sneak that in there. I saw that was a whole number. At 2, I'm going to do -1.7. Oh, one off there. So at 2, I'm at 1.7, which is here. And I just realized I'm doing these all upside down. Let me flip these. So flip this down. 4, -9.5. So this is 8. We're actually down here. -2, 5.3. 0, -3. Here. 2, 1.7. All right. Now we're good. All right. So let's go to 4. I need to shift my graph down a little bit. My apologies. So at 4, we're at -9.5 or 9.4. So that's a little bit past the 1, just underside. 6, we're at halfway. And 8, we're at 0.3. So again, more steep more quickly, and it's flipped upside down. Okay? So there you go with number 2. Let's shift over here again. To number 3. Can I sneak this guy? Guess we can put it here. So I have basically +3 times 3/4. Let's change our exponent. So our exponent will be x plus 4, close parentheses. And then I'm going to add, it's not add, but subtract 2 from that whole thing. So, you can gander here. There she is. So it looks like it shifted it down 2 off the x-axis and made it a little more vertical. Looks like we also have a shifting to the left going on. But let's look at our t-chart so we can graph this. We're going to go out to -8 here. And then again, I'm going to do sets of 2. Okay, so there we go. All right, so -8. We're going to go up 7.5. So 7.5 is here. Another purple, I thought. -6, 3.3. 3 1/3 of the way up. At negative, let's see what, -4, we're at 1. At -2, we're at 0.3. This is where you get on the negative side of things. Let's shift this down. Let's get 0 up here. One too far. So 0, we're at about -1. 2, we're at -1.5-ish. 4, we're at -1.7. Okay, now it's starting to level off. Notice the changes are very little here. -1.7. Okay. So your horizontal asymptotes, when we start talking about asymptotes, I know it says it right here. Okay? And then we had the y-intercepts we need to talk about. Okay. So let's start going through this stuff. As far as the asymptotes go, let's go back to the first one. Our asymptote is this line here. Where is it getting to but not crossing? So our asymptote in this one is y equals 0. Okay. So this case it's the x-axis. As far as your y-intercept goes, so this guy It is y equals 1. Or you could write it as 0, 1. Okay? So let's go to the red graph. Let's start with our y-intercept. Y-intercept here is 0, -3. That one's pretty good. How about our asymptote? So this one looks like, again, it's getting really close to this line, where the x-axis. That's y equals 0. Okay. Purple equation. I'm going to have to jump back to our graphing calculator to get the exact value. Turn that on. So it looks like our x-axis, or y-intercept, this case is different. Okay? Is -1.051. Our asymptote, in this case, is right here, which would be y equals -2. So that's going to get close to y equals -2, but not cross. Okay? So, let me get this stuff out of your view here, so you can see the whole picture. And there you go. Okay, for the last problem I want to get you started with, okay, is just getting this set up. So let's get this set up at 25,000, that's your principal. You're going to have 1 minus your rate raised to your t. So, when we start doing this, 25,000, 1 minus, we're losing 15% a year. How many years? So when I write this in the calculator, I'm actually going to do the subtraction while, okay? So it's going to be 0.85 in here, and instead of t, x will represent t. So this is t here. So when you hit graph, you can actually see what your car will be worth in what year. Now, there's your model. Okay, your model will be y equals 25,000 times 0.85 to t years, which is where we put our x. Estimate the value of a car after 4 years. Well, to do that, just go to your table. Where's x for? After 4 years, our car is going to be worth $13,050. At 10 years, we're going to be worth $4,000, $921.90. So $4,921.90. And then in year 25, probably pennies. Let's take a look. You got to go all the way down here to 25. So it looks like $429.25. I hope you had a lot of fun with your car, because it really isn't a good investment. Did I write that wrong? Yeah, it's 95. Cars are usually not going to be a very good investment. Usually. Every now and then you can make some money. Estimate when the car will be worth $8,000. Well, let's go to our y values. When we see 8,000 here, we'll know when the car will be worth that. So about 7 years in. So, did it give us a year? Nope, about 7 years. Will all be worth 8,000. How long will it take the car to depreciate completely? That would go to infinity. Okay? Car will never actually be $0. Because obviously it'll worth scrap. We'll get close to that, but it will never be $0. It'll be infinity, and infinity will always be a little bit above $0, but you never quite get there. So if you actually make this chart run all the way out, even at 100 years, this is still going to have some value. It's not going to be a lot, and you're not going to be happy. You can see we're still worth $2, $1, and I would doubt that you would even get to 10 cents, because just in raw material, your car will be worth something. All right, ladies and gentlemen, that's this section. Hope you enjoyed it. Make sure you get fluent with the graphing calculators and bounce questions off me, all right? Good luck, guys.